So yeah, being that this is the first one, we're going to see how this goes. It's a bit of an experiment for everybody, but I'll just frame what we hope to do with these sessions. The big intent is to just be of service to developers in the larger community. We know most, if not all of you here are working on some sort of project. We've talked in private and in public a little bit about what everybody is working on. But at the beginning of each session, the developer we're featuring will give them an opportunity to share a bit about their project, what they're working on. I know David's itching to share some library that he's been working on, so that's kind of exciting. And the big intent of these sessions is just for us to be of service to you, to help unblock you on problems you're having, or walk alongside you, provide some mentorship to help you make sure that you're kind of on the right track, that you're using these tools that Holochain provides in an idiomatic way, um, and hopefully to foster some sort of mutual learning, teaching type stuff. We encourage people to have secondary conversations in the chat about what's going on. So after an introduction for the VIP of the week and some whatever you want to bring, questions, code to review, a sticky design problem that's blocking you, something like that, then we'll open it up to everybody and we'll talk about the sort of answers that we came up with, and if people need clarification, you can ask, but I'll be there in silent mode in the chat as well, helping people with sort of side questions. So yeah, so the first project we're featuring is David, Lynn, and Bob from I don't know if you're all under the umbrella of mycorrhizal software, but the project you're working on is HoloREA, which is meant to be, I believe, a generic resource events agents accounting library for Holochain. So yeah, I'll let you guys talk a bit more about the project and we'll take it from there.
All right.
Okay. Okay.
Start us off with REA.
Yeah. Okay, so a couple of things I would like to make clear up front here is we are trying to create software that other projects can also use to create economic network applications using Holochain. That's our focus, economic networks, in particular cooperative economic networks. And one of the reasons that we want lots of other people to also use them or use something like them or use something compatible with them is we really want to develop a cooperative economic system. And so we've been working on this for quite a while using other technology, and it has become clear to us that really what we want is, because everything we're doing is sort of peer-to-peer from a human standpoint, and we would like to also use peer-to-peer technology. Thus, we are working on something for Holochain, and so I'm going to do a little bit of an intro of the problem that the first problem we ran into, which is REA is a very compact economic model, but it is also highly relational in that everything is connected to everything else. And so the two ways that you can do this nicely are with a relational database or with a graph database. And so we're trying to know, how are we going to do this with Holochain, a DHT, which is neither. And so David has figured out a way to do this, and he has it up and running in HoloProto. And so he can. I'm going to hand it over to David to describe what this is. Also, he's putting this out as a library that anybody can use, whether they're using the rest of our whether they're using the rest of our framework or not. They can take that and play with it in a variety of different ways. So I'll let David take over now and describe what he's done on that so far. And then you can also bring up the child question, which I said, anytime you solve one problem, it has children. So I'm going to mute them. David, it's on you.
All right, thanks, Bob. Well, like Bob said, the previous REA implementations were using relational databases because there's a real rich network of interleaved knowledge and observation in an REA type model. And the relationships need to be configurable. Like they're not always stored in one place. We want them to be shareable. And in particular, there's a lot of different forks of previous REA software that we've all worked on, that Bob, Lynn, and I have worked on, such as the NRP for Sensorica that have all this legacy data. And we want things to be sort of interoperable, so we don't want to make a lot of assumptions about having our data all under one app in the DHT. And REA is sort of divided into layers, which is like knowledge layer, observation layer, and planning layer. And all these user-created objects need to be able to configure other objects. So there's no level of the model that's an island. Everything needs to be highly interconnected. So what I wanted to do was basically fake an object relational model from within Holochain using the links entries. Because I noticed they're like a primitive of a foreign key. They're very similar to that, except they don't have as much declarative power in terms of, like, you can't declare a link to be one-to-one. You can't declare it to be many-to-many. And often you need to have things related both forward and backward, like in both directions. For instance, if I have an event that affects an apple, let's say we have a resource that's an apple. I have an event that'll affect it. We'll say bite. I'm going to take a bite of my apple. I need to set a property of my bite effects to be the apple, and ideally later someone can pick up that half-eaten apple and say, well, what affected this apple? Who bit it? And they can look back at its affected by property to determine that I was the one that bit it, and they can, I don't know, charge me or whatever. So whenever I started doing that, I started out by making fields that emulated the relational properties. For example, my event class would have a field called effects, and every time during my Zoom functions that someone did something that would affect effects, it would load up the event, store the hash of whatever it affected, and save it back, and then simultaneously do pretty much the same thing with the link in a separate links entry type. And I found that it was so common throughout all of my classes, not just event, but resources, resource types, agents, everything. It was so common that I just had to abstract it and turn it into something automated. And the pattern I've come up with is more or less this. I would split each object that I was modeling into a scalar field class and a reference field class. Like in my DNA, there would be two separate entry types. In this example, the event would have an entry called event entry, and it would also have an accompanying field or an accompanying entry type called event links. And all of the relational fields that I would have otherwise implemented as foreign keys, I instead plucked out of that scalar field entry, took it all the way out of the schema and everything, and instead implemented each of those properties as links, and the property would be identified by the tag whenever you went to link something. And that had the additional benefit of being able to quickly query for fields that had multiple, like one-to-many type fields. And again, that was still a little bit too much boilerplate, so I came up with something called that I called a link repo, which is a library for TypeScript that I'm gonna paste at you in a second in this chat.
Can I ask one clarifying question too?
Absolutely.
You mentioned using the links, like the links API of Holochain,
Yep.
but you also are creating a separate entry type that sounds like it's representing foreign keys.
The links do represent the foreign keys.
Okay, but did I hear that you're creating a separate entry type, which is that a links entry type, or is it an entry? Okay, okay, gotcha. It's not an entry that has fields which are hashes of other entries.
Correct. It's like the other half of the class.
Gotcha.
The class itself is split entirely in two. And one of them has all the references, one of them has all the scalars. And for events, we actually have very few scalar fields, but they're enough to make sure that the individual entries hash differently, because you don't want to have everything stored on the same hash. Otherwise, your links are not going to be very effective.
Mm-hmm.
All right, I'm just going to share with you the link to the repository. Now, I called this library link repo because a repository is a place where you put stuff, and at first, that's basically the only thing I wanted out of it. But there were a lot of other things that came along with it. For instance, the automation. I'm now able to create any of these traditional relational fields like one-to-one, one-to-many, many-to-many in just a couple of lines by describing the rules that make it that type of entry or that type of field. For example, if it's a one-to-one field, I can generally say that setting it to one thing means it will not be set to anything else. And these link repo objects, they
David,
represent.
could you share your screen? I'm not sure if you're looking at code right now.
Oh, snap. Just a moment. I'm actually I'm on my phone, so
okay.
just a moment. I'll get there on my laptop and I'll be right back.
Okay. Or you could send me the link and I could share it. If that's easier.
Well, it's a running Holo app, so
okay.
Anybody could, of course, download it and use it themselves. But if you want to play around with it,
yeah, he's also got. He demoed for us yesterday. He's got a REPL for this. Read, evaluate, loop. So you can actually play with this as if you were in a program shell from the browser.
Yeah. Now it's not perfect. As far as it's not exactly like being in a TypeScript source. For reasons that are kind of obvious, like you don't have access to the type definitions, and the type definitions are a big part of what a link repo turned out to be. So you don't get that. You don't get protections with the tags. One of the things that's remarkable about TypeScript that that I've been leveraging is that the types are extremely expressive. Whereas with just entry types, it's sort of the wild, wild west. Like you could theoretically put whatever tag you want into an entry. You can give whatever entry type you want can go into a single links entry. There's no restrictions at all. So I could theoretically, just as an example, make one links entry for my entire program, for my entire app, and put all of the links for the entire project in there, just lump them together. I would never do that. That would be a dumb move, but there's nothing in the Holochain stopping me. And so I decided to take it one further, and the link repo, as part of its type when you declare it, will actually limit the types and even the tags that you can use. And as you're typing your code to instantiate a link, it'll actually tell you, if you've got your IntelliSense, which tags are available. So it's very difficult to forget, very difficult to mess up. And I'm just,
I see, because you're encoding it into a type, a
right.
type. Mm-hmm. Cool. So you get compiler time feedback.
Exactly.
Mm-hmm.
So you won't get a lot of that on the REPL, because it's a client side application. It's all the types have been compiled away. They're gone, never to be seen again. And but you can really just play around with it in a more or less opaque way. Just an update, my Zoom client is installing. I'll be able to show you guys a screen share probably shortly.
Gotcha. Yeah.
Mm-hmm. In any case, with the REPL, you can make opaque objects. Like it could be just whatever your project needs. All the link repo needs to know about is its name. You're just going to give it a name, and you can pretend it has all kinds of properties if you want. And if you want to give it other properties, that's great, but link repo doesn't care. And you can set up individual repos that encapsulate a group of tags and the rules that that you want to be assured of when you instantiate them. And there are a couple of forms you can do that in. You can create singular rules, which is like one-to-many or one-to-one, in which case when you create an instance of the link, it'll actually get rid of any instances that came before that. So there's no need to go back deleting, back to this events example, I wouldn't need to delete the link to the old resource that it affects if I was to change it. It would just happen automatically. Just the way it would in, say, Django. You would expect that you just have to set it once. You don't have to go back and set it from the other side. And
so does it do things like if you want to create a one-to-one relationship, it'll create links on both sides?
Right. You create one end, and the other end just follows.
Mm-hmm.
And you can also create reciprocal links, which is, for instance, if it's a pair, like the event in the resource affects and affected by, you can set that up as well. And if anytime you assign effects, it will also create a corresponding affected by. And it'll also track the one-to-oneness of both of those sides independently. So it's all very configurable and fine-grained. just got to give myself a name here on Zoom.
Sure. Yeah, just some reflection while you're doing that. So Bob mentioned at the beginning, the perception is that Holochain is neither a relational database or a graph database.
Right.
And it sounds like you are making an abstraction that lets you think of it as more of a relational database.
Precisely.
Which is interesting because I've always thought of it as more of a graph database.
It natively is.
Right, right. Yeah, but it really can go either way because, I mean, it doesn't have things like graph algorithms that a graph database would have. It's very general, right? Just providing links. So this is interesting. A way to see it as relational.
So, by the way, Michael, we will be developing graph algorithms to work over this stuff. In other words, this is the REA model as we have developed it is for economic networks that do present themselves as graphs of resource flows. I did want to comment on one thing, that when we're talking about events here, REA events are economic events. Events is a very overloaded word. It's not like an event that you go to a party. It's more in the sense of like event-driven programming. Resources in REA are affected only by economic events. So if you have so in other words, you can it's like a log. It's like a database log. You can replay the whole state of the resource by traveling through its economic events, and the economic events then go through process flows where they're connected to other resources, and so you can travel from. So it's like there's a high school Fab Lab network that's using this stuff in Milwaukee, Wisconsin. So they have a whole bunch of high school Fab Labs, and they share inventory. They will post what they have available, and that then can be requested by another Fab Lab in Milwaukee, and the library system will run it back and forth with library trucks. And so then they can tell where that resource came from, and they can also tell where they got it because they get donations from companies. So it's like you can travel through all that stuff by means of links. And so with David's link repos, we'll be able to do that kind of thing. Mm-hmm. Okay, I'm going to shut up. Give it back to David.
Cool. Yeah. And Holochain is great for that, of course, because you never really modify anything. So like, in the case of an economic system, you would never store account balances, right? You would just store the transactions as events and then sort of deduce the balances. And yeah, that's, we never modify anything in Holochain. It's an append-only log, so it's great for that. Yeah, I'd love to see some code though, if that is soon to be.
Yeah, I see two Davids on there, so he must have the laptop and the phone going. Yep. So, David, if I could reflect on what you've been talking about, it sounds like you have both.
You couldn't hear me, could you?
No, you were muted. Yeah.
I'm still working on this.
Okay, alrighty. Yeah, while you're working on that, it sounds like what you're doing is you're defining a way to ensure some structure around links, so that you're not doing things that you're not supposed to do, like sort of defining a schema, I guess, for relationships. And
that is very close to what it is. Yes.
Cool. And is it also true that so you've got the sort of links repo, and you've got the other stuff? I forget what like fields. So it sounds like fields are in other entries as well. Would it be true that you're kind of creating like an entry attribute value sort of pattern on Holochain for like really flexible schemas kind of thing?
Yeah, that's pretty much it. It's very close to formalizing and organizing those relationships. And I'm sorry, guys, I cannot get this thing to share my screen
Okay.
without. But you can install it. I promise it runs. And when you turn it on, if you just visit index.html, if you type the word Zome, you'll know how to spell Zome, into the REPL, and it will give you help for anything that you can do with it.
Cool.
So,
about membranes and how to kind of define sort of private and public things. I know you're working with
yes.
like, the insides of organizations and the outsides of organizations and stuff like that. And I think those would be sort of fruitful things to discuss too. So if it turns out that we can't demo that kind of stuff, it might be good to move into those conversations instead.
Yeah, that's a good idea for at least the meantime. What I've really wanted out of Holochain, what I've been searching for is some way to dictate on a instance to instance basis or entry to entry basis who can access what data. And it sounds a lot more complicated than what I'm really asking. If you just think about a Facebook photo, you can choose to share that with your friends or coworkers or whatever, and you can also choose not to, but it's still up there in this case it would be the DHT. It would still be out there shared, but you could also control who gets to see it. And we want to kind of do the same thing with economic info. Like if you need to describe a process that you're using to distill cider or whatever. If you want to share your process and your schedules for when you're doing that type of stuff and your inventories, you can do that with the people who are part of the same project or who are involved, or you could just share it with anybody. But it should be that agent's prerogative. Should be able to decide on a case-by-case basis, if possible. And some of the limitations that are built into Holochain are that you have entries either designated as public or private, and that's it. That's what they are forever. So if I designate something public, then anybody can see it regardless of where they are. And if I designate it private, it becomes very difficult to show that to collaborators at my discretion. So if anybody has any ideas about that, I would love to hear them. Some of the things we've considered, or that I've considered that are probably not working, is for less important data, just sort of put it out there and count on nobody guessing the hash. And I'm talking about really not important stuff. I would never, ever do this with like a credit card number or something, or even something less important like someone's actual real address. But in that case, supposing that I had something that was hash private, I guess that's what I want to call it. Like the hash is secret, sort of. Hard to guess. Let's call it hard to guess. And but the entry is public. You would be able to easily share that hash to share the data. Whereas you couldn't do the same thing with the data that's been committed to the local chain. You can never just share a hash and say, "I'll check this out. It's at this hash." They won't be able to access it.
Right.
Now, of course, that idea doesn't work. The public hash that is just hard to guess. That it's probably not good to use that for anything.
Right. So the analogy to things we see on the internet now would be like a Google document with a link where anybody who has the
Right.
link, right, can access it.
Precisely.
So, right. So in some cases that's what you want, but certainly there's more privacy settings than just a shareable link.
Mhm.
And yeah, it is different in Holochain. What you mentioned about links or entries being either public or private is right. That's sort of the basic options you have for visibility within one DNA, within one app, right, within one membrane. And it's, because of the nature of how we need to replicate data, basically if anybody holds the data, then they can serve it up to anybody else for replication purposes. So within one DNA, all public data is indeed public. But we're expecting to see actual applications composed of many DNAs, right? And I'm not sure if you've touched on this topic before, but so an example would be for like a Slack-like app, some sort of chatting app, where you have private channels. It's not quite public, it's not quite private. It's a shared, it's a space where some certain number of invite-only people are allowed to freely share information, but not to the wider audience. And the clean way to map that onto Holochain ontology is you spin up a new DNA just for that private channel. It has all the same functionality as the main chat app, but it's a different DNA. So it's invisible to everybody from the main DNA. And use bridging to coordinate those two. So you have public entries in a sort of private DNA.
It's interesting. I can consider that as a membrane.
Right.
You can separate things was just by having a totally different DNA out there. It's neat.
Mm-hmm. Yeah, because these DNAs, they're lightweight. You can have many of them, and they mainly do represent, they represent a set of rules that you play by, and functionality, the actual functions that you write, and they represent a membrane that people can be invited into. So, you can widely publicize the main DNA, and you can selectively publicize a more private DNA for people to install, and also have rules for them joining the membrane, because you can have a whitelist, like an allow list, where only agents of certain hashes are allowed to join, and if anybody else tries to join, then the other agents just kind of keep them out. So you can enforce that sort of group private status that way.
That's a good idea. I can use that, right?
Yeah. As far as I know, it hasn't been actually implemented in any Holochain app, but it is like definitely the pattern for that sort of private sharing. Now it maps cleanly in the example of a chat app where every member in that private DNA is can see everybody else in that private DNA, but it may look different for different forms of different sort of topologies of private sharing. So can you give an example of something that you would want to selectively make available in your case?
Let's see.
Well, one example would be people working in a project together, or even on just one process together, would want to be able to collaborate and see everything that each other is doing, but not necessarily have that open to the world.
Yeah, that sounds like
it'd be like a chat. Yeah.
Yeah, exactly. So what it might look like is you could sort of on the fly, there could be this ability to sort of copy over almost all of the same DNA, but change one little thing, which would change the hash and make it a totally new network, which has the same functionality. once you do that, you have a DNA hash. You can, send that DNA to other people that you want to collaborate with. You could even put, a reference to a certain entry hash of that new DNA in your main DNA for people, for your collaborators to go find it. Which is fine, because if you have the right validation rules in the new DNA, people who aren't supposed to be there can't get in anyway.
Okay.
Yeah.
This
You
is
see kind of more go ahead, Bob.
No, go ahead, Lynn.
Well, I was going to say I see more difficulty on things that aren't quite as clean as a group working together, like a supply chain, or even just kind of individual exchanges and transfers of resources. Although maybe that can just happen with sharing through private, through the agent.
There's
I don't know.
Send and receive, right? That's the fallback. If all else fails, you can always just send and receive stuff.
Sure.
Right.
Yeah. So you can do direct messaging, which of course has the disadvantage that your node has to be offline.
Yeah.
Online. Sorry, it can't be offline. And of course, there's private messages or private entries, which again, you have if you publish a private entry and then you want to give somebody access to it, you have to be online to do that, because you essentially send it to them directly. If you want to give them access to it selectively through capabilities, we're building a capability system where you can sort of provide a capability token to somebody else. And then when they give you that token, then you will send it to them. But you have to be online also, so it has that disadvantage.
Right. Is that available in the Go prototype, or is it unique to the Rust version?
It was never fully implemented in the Go prototype, and it's being worked on in the Rust version. Yeah.
Yeah.
Just one more thing. It's kind of an anti-pattern, but for information that is maybe, for information that will not be important 10 years from now, you can use encryption. You can, publicly publish a message and encrypt it. But I say it's an anti-pattern because we're assuming that encryption will be broken at some point, right?
Okay.
Like as machines get more powerful, maybe with quantum computing, we're not making assumptions that encryption will actually offer, absolute privacy. But for, on a case-by-case basis, maybe it would make sense for something, if it's not, if it's only needs to be private for the next year or so, 5 years, you can hedge your bets, but that's one option as well.
Yeah, that was my plan B or something like that. Among ways to hide things in plain sight, that's encryption was a not bad one, right? But I guess not forever, huh?
Yeah, it's pretty dangerous to have to publish something publicly that's supposed to be private in an append-only log that's supposed to last forever. That can't be deleted. Yeah.
So I wanted to call out for our gang a couple of things from this set of the conversations here that I think are going to be important to us, that were new to me. One thing in terms of the different DNAs, swapping DNAs around, we want to have a framework for other people can use, but we also want to build some apps on it. And so one of the main apps that we want to do is a combination of social and economic networking. So we want to have it be like a combination of chat and economic information. So, if you're all working together on a process, then there's a lot of things you want to say to each other about that, that are not themselves economic, but so you can't make it so rigid that you can't have that. So we want the fluidity of a chat with the structure of a base camp for a collaborative economy. Yes. And but with also very structured economic interactions that actually work the way they should have. By the way, for Michael, for Michael, one thing that I did wanted to drop on your mind is that, as far as I can tell, from as well as I understood the category theory class, the REA model is compatible with category theory. It works. What we're doing works the same way. Okay, I'm going to shut up now.
Okay. Yeah, I mean, from, you know, I never made it very far in my understanding of category theory, but I do understand it's sort of the science of composition. So I can see how that makes sense, but I'd probably have to study more to really back it up. But to talk to your other point about chat alongside with sort of economics and economic flows. As I mentioned, you know, it's easy and expected to have multiple DNAs for an application. So we talked about the case where you have, you know, many DNAs that all offer the same functionality working together to sort of build up the same application. But you can also have different DNAs with different functionality, right? So you can have your economic app as one DNA and your chat app as another DNA, and they can be unified under the same interface. And that's really how we're expecting apps to look. Each DNA is sort of like a microservice, right? So like Facebook is composed of many microservices. Like there's probably one just for likes, one for, you know, image storage, all these things compose together to make that social network. And so, you know, same with DNAs, but they're, you know, completely modular. You can have a chat app a chat DNA that's used in perhaps many other applications. You know, maybe one is a Slack type thing, one is the economic network, one is like some comment thread, right? Like you can repurpose the same DNA for many different apps by plugging it into different UIs.
So DNA is actually a module in addition to zones being modules. That's another boundary there. Like you can actually form your app out of lots of DNAs, is what you're saying.
Right. It's less clear in the prototype version, because the prototype version, you don't have to do this, but by default, there's this notion of pairing one user interface with one DNA. Because when you run HTDev web, it spins up the UI in the UI folder and the DNA in the DNA folder.
I was thinking that was just intrinsically how it was, because that's how it was set up. It hadn't even crossed my mind that you could compose an app out of a whole bunch of DNAs.
Right. Yeah, which is a reasonable assumption, because that's how it was presented in the prototype version. But that's mainly for convenience. And even in the prototype version, you can spin up a DNA with no UI and simply call it from, you know, as long as you, like for the prototype version, you could spin up multiple DNAs on different ports, and then your UI can make requests to the different ports to pull from different DNAs. Yeah. So bridging is also it is a very important concept, but it's going to be even more important once it's better implemented. There's a very rudimentary version of it in the prototype version. But you know, that's sort of the pattern for getting multiple DNAs to talk to each other directly.
Right.
Right. So yeah, in the Rust version, the way it's structured now, the DNAs are completely divorced from the UI. I mean, there will be a coupling, but a very loose coupling. Like a UI will know that it has to have certain DNAs in order to run.
Like a package.
Sure, yeah. It's like, hey, exactly. Like this UI might have these DNA dependencies, but the DNAs don't need to know about what UI they're running under.
Okay.
Yeah. So
that's good.
Yeah. So it's kind of it's kind of the norm for multiple DNAs to be running together, all in one. Right now, we're calling it a container. Yeah.
Okay. Now let me ask you this. Is there a realistic prospect of having Rust Holochain apps calling upon or bridging to Go apps, Go Holochain apps?
So in the Go version, bridging is accomplished through HTTP.
Mm-hmm.
In the Rust version, it's going to be much more. It's going to be managed by an actual process. So it's going to be sort of. It's not going to be using HTTP. So no, not really.
Okay.
But bridging, bridging between Rust and Go apps will not work. But
Okay.
you could have a UI running that makes calls directly to, you can have a UI that calls your Go DNA and then also calls your Rust based DNAs. Because at that point it's just two different services that you can access over. Actually, in the Rust version, we're using WebSockets. So you would start a WebSocket connection for the Rust DNA and HTTP calls for the Go DNAs.
Right.
But they wouldn't be able to bridge directly.
Okay. There was a question, right? I'll shut up then.
Yeah.
Sure. Let's see.
Ryan's trying to ask a question.
Yeah. So what would be the most granular unit you could go to for DNA? Each REA was in a new DNA. Would that become unusable? I see. So let's go to Zome, right? Like that's one unit of composability. That sort of corresponds to a module of functionality. So you might have a Zome that's very useful in a lot of different DNAs. So that's more for the benefit of the developer to be able to sort of plug and play these useful packages together to make a DNA. So that's the sort of boundary of composability for Zomes. For DNAs, that is, it's kind of the fundamental unit of composability for Holochain. It is sort of the rules that everybody in that DNA plays by. It represents the membrane that wherein everybody in that DNA can access the same information and is sort of assumed to be playing by the same validation rules. So it's these sort of higher level decisions that make you decide how to choose what is in your DNA. So one thing to consider is that if you want like links happen between entries in one DNA. So if you want a link between a resource and an event, they have to be in the same DNA. Right. So as soon as you want to draw that new membrane where you won't have the same membership, you're running on a completely different network, then you'll want to use a new DNA. Does that answer some of that question, or is there a follow-up?
Yeah, I was just thinking of patterns that David could use to so he can invite other, when they're talking about sharing at different levels. And I kind of feel if you've got the whole, if you'd have to know what level of sharing you want beforehand, if you're going to bring different people into your network. So ideally, if you could break it into the smallest possible unit, then you could share it out at that level. And if you want to share, 100 different, I don't know kind of where you would break this up. If you're sharing out 100 different resources all at once, you could do that. Or if you just want to share one, you could do that if you break it down in the first place. But if they're already in one app, then you can't change the granularity of that later.
Right.
So with the multiple DNA approach, it's more about, you have to choose up front or at some point which agents you want to share it with, and then you decide which entries to put in that space. So you kind of you create the space, you decide who to share it with, and then you populate it with entries, which allows them to be propagated and limited to that group of people. So yeah.
So if we had like a situation, I'm thinking something that would look like a Venn diagram where we have groups on, we have one group of data, two groups of data, and there's an overlapping section, and then we bring in a third agent to this, but we don't want to share all the data with them. We only want to share part of this data and part of that data. We can't just draw a new circle that only encompasses part of that data. We need to share the whole circle.
Mm-hmm.
I don't know if that described it well. That
because right, because as you add more people, like within this call we have 8 people, and there's an exponentially larger amount of different subgroups of us, right? So it would be crazy to have a different DNA for all of those. I think what is it, like 8 factorial? It's pretty big number.
You could make can you sort of make DNAs at will programmatically? Is that within the realm of possibility? Like just to make a new group with whom to share something, could you say, let's split our DNA, we'll clone ourselves right here from within that application and say, here's a new domain?
Sure. I mean, it's something you would do outside of Holochain. I mean, okay. It wouldn't be the actual zone code that would be able to do that, right. But you could certainly do it, and also consider for certain interactions you might not need Holochain, right? Like the things that Holochain are good for. Like for instance, if you were if you want to like start a video chat, you wouldn't use Holochain for that. You might use Holochain to have like a lobby where people can find each other and start video chatting, but then you would kick it off to an actual direct connection using some actual video software,
Right.
So there might be cases where you jump off and don't use Holochain for some private interaction. You only use Holochain if you want everything Holochain is good for, like this sort of immutable data store that you can be confident people aren't tampering with, and the resilience and the ability to work with to detect agents that you don't trust and things like that. But if you're inviting people into a trusted space where you don't need those things, just do it off of Holochain, or do it on Holochain. Basically, like Holochain, just as an app can consist of many Holochain DNAs, it can also use services that aren't Holochain too. Holochain is a tool, right? A framework for a particular kind of organization and data replication and integrity. And you can build some apps entirely out of it, and in some cases, there's going to be many new use cases that we can't even imagine, and I'm sure some of them will involve some hybrids.
Do we have time for like one more thread of one more line of questioning, or is it getting closer? The future of TypeScript looks like for Holochain. Like assembly script, I know that there's an HDK in development, but it looks like the assembly script itself is not. It's not a very robust technology. Are they still moving forward with that? And does anybody have ideas about the best way to not throw away as much TypeScript as I've got?
Mm-hmm. Yeah. So we had high hopes for having an assembly script HDK. It turns out that I was actually working on that a bit myself, and I saw firsthand. Assembly script is very it's very new. It's very immature. We had to write our own JSON parser. There's some very basic stuff that's just not implemented, and it's my hope is that as it matures, it'll become more viable as an HDK target, and I would think that that would be our next target for writing an HDK.
Mm-hmm.
Yeah, I think we're in a similar boat. We thought that TypeScript was going to be more viable, but I think we have to wait for AssemblyScript to grow up a little bit more. Yeah.
And meanwhile, how much of a shock is it in terms of just capabilities? Like, is there a lot of stuff that I cannot do in Rust that I can do in TypeScript? Let's say like closures. Rust has closures, right?
Rust has closures. They're a little bit more difficult to work with because you have to, its memory management is a lot stricter. But yes, yeah, I mean, ultimately, I mean, they're both Turing complete, so you can do the same things, but
right.
that's a cop-out answer. But yeah, Rust is a fairly expressive language. You can do closures. It has a nice channel system for asynchronous stuff, like using message passing.
Right.
But yeah, it's definitely a heavier-handed language, and it generally takes a bit longer to write things in that one.
Yeah, it kind of looks like, God bless them, they still have pointers.
Yeah, but they're managed for you so that you can never have a null pointer exception.
Oh, that's good.
Yeah. It's kind of a pleasure to write Rust in its own right, even though it can be time-consuming. Let's see. Oh, Paul's question real quick. Do you have to explicitly bind variables into a closure in Rust? Not explicitly, but you have to make sure that all the ownership properties are correct. And like Rust has this concept of ownership, which is quite unique. But basically you can't, it will automatically pull values into a closure for you, but you have to make sure that you're not pulling those values away from something else that's going to be using them later, or else it won't compile.
Okay.
So things like that. It won't just clone values for you willy-nilly. You have to do some things explicitly sometimes to set that up.
And it has a habit of throwing things away, right?
What's that?
If you return and aren't using something, it has a habit of like throwing away your local variables. Is that correct?
Well, it just won't let you do things that aren't safe.
Okay.
Yeah, it's really good about that.
Clever. So it looks like we're at time here. This is a really kind of fruitful and engaging conversation, but I also want to be respectful of everybody's day. Do we want to keep going for a bit longer, or do we have places that we want to go to?
I can go for a few more minutes.
Okay.
Yeah, same.
All right. Ryan.
I'm good.
Okay. Alrighty. Ryan, are there any other questions that you had on your mind, or David?
No, I'll go for it, David.
No, that's all. Go ahead.
I was going to just say I didn't have any right at the moment. No, have you got any more any information to where we'd find more REA resources?
Oh gosh, there's tons
Go
and
ahead,
tons.
Bob.
Unleash the links, Bob.
I'll put them in that should I put them in that happy hour channel?
Oh, okay, awesome.
Yeah. Okay.
That'd be
And
wonderful.
the other thing, I was looking through some. I was just going through the code. So it looks like you've kind of got your own test system there, do you?
This is the link repo, the REPL.
Yeah. So
HoloREA.
in the REA.
Okay. Yeah, that was a very early move that and I think it was a mistake now to sort of mock the Holochain API so that I could test things before the DNA was in a working state, and sort of have more robustness than the test platform that ships with it. I didn't mock the entire API. It's just the part that I used. I was extremely lazy. and it was a terrible idea. Nobody do this. I ended up making a bunch of assumptions about what the API knows at certain points, and it was a terrible idea. Nobody do that. But yes, I did mock the API. I really wanted to use Chai to do my testing, or do my testing in TypeScript at least, but not in the cards. It's a bad idea.
I know I've started using the Rust version, and they've got a lot better framework there than in the Go version. So yeah, you can. It's a lot more powerful and flexible anyway.
Oh yeah.
If you haven't had a look at it yet, yep.
Yeah, it's nice because basically you just use Node.js for testing. You fire up two instances of your app using the Node.js library and use whatever. I think most people are using Tape, but I suppose you could use like Jasmine, Mocha, some sort of Cucumber-like framework, whatever you want. So,
does it have a built-in back and forth?
Yeah, there's a sort of, if what you mean is like, is there sort of a fake DHT and network, then yes, there's a mock network. So, and it even has propagation delays, so you can get a real taste of what it feels like to be waiting for data. So, don't know if that was intentional, but it works out great for testing.
Yeah, that's one of the things I was missing. The delays.
Good old non-determinism.
Yeah, but the REPL is it tests based on the actual DHT, so that's a little more realistic. I would not recommend. In fact, I might just go delete that mock. That was terrible.
Ambitious project, though. Wow.
Sorry?
Ambitious project to mock the Holochain API.
It was just a couple of functions, just the basics.
Yeah, fair. So,
Yeah, no, I was going to say there's a lot in that repo there. Have you I noticed you haven't got the validation in there yet either.
Right.
Yeah.
Well, the idea is to have something that runs that you can see before we start getting into the details of especially like domains, because we're not entirely sure where we want to draw those domain lines yet and what the entry points are going to be, because it is going to be a modular app that you can drop in to a lot of different places. So while I learn about how to access things differentially with different levels of access, it's just going to validate everything, and just until we have figured out where it runs and where it's not, what's going to be valid and what's not.
Yeah, cool.
And
Hey, oh, sorry. Yeah. No, you go.
Just wanted to say with validation, with the Go version, there's the declarative schema-based validation that was a first pass at making sure that the data structures were correct. With the Rust SDK, or actually with the new Holochain, there is no sort of declarative schema validation. But
what?
There's what part?
There's no schema.
There's no schema validation, so you don't like write out a JSON schema file for each entry. However, because the structure of the object is in Rust code itself, and it's all, static type checking and stuff like that, the compiler will tell you if you're doing something wrong. So it's kind of a essentially the same as JSON schema, I guess.
Right on.
Yeah.
Now, does Rust have Rust has some pretty, I'm assuming they have good development environments, right? And it'll probably tell you, for instance, if I only want certain strings to be passed to a function, I can express that in Rust. Oh, we were just talking about this yesterday, Paul, right?
Yeah, enums are useful for that.
Yeah. Well, that's pretty cool. Will will that show up in any good development environment? Is there one that you could recommend?
The environments are all a little bit immature. I mean, it's nowhere near Java or more, more mature languages. But I mean, you'll certainly get compiler errors. And if the environment is good enough about showing them to you in the editor, then you'll see it there too.
Yeah,
TypeScript is very cushy like that.
Yeah, no kidding, eh? I tried the Rust Extended or Rust Enhanced. It's the official package for Sublime Text, and it will do inline compile errors. So yeah. You might have to save the file. I'm not quite sure. But yeah. Ryan, I feel like you had one more question there.
Sorry, what was that last thing?
If I
Yeah.
Oh, if I did have one, I think it's gone out of my mind. It's 2 a.m. here. I'm not too sharp at the moment.
Thanks.
Well, we should probably let you go then. Yeah. Well, I think this is a great first session. Thanks, everybody, for coming out.
Thanks for having us.
Yeah, it was wonderful. I just loved all the sort of deep discussions of architecture and design and stuff. So, yeah.
That question just flew back into my mind, actually.
Okay. That happens.
Sorry, bumped the button. This one's about licensing. So I know this seems to be coming up more and more in the Holochain world, but where you said your library, you're planning on being a reusable library, and you've got it under GPL license at the moment. Is it your plan to stick with that, or is that just like an interim waiting and see what happens, or?
That was something that I asked our patron about, and it was handed down from on high, and I'm happy with it. No reason to mess with it for me. You will have to ask. You'll have to ask Art about that, and if he says change it, we'll change it.
Okay, yeah. I'm interested in. I don't quite understand the implications of GPL in the Holochain world, and where kind of the boundaries of what's classed as linking to an app, and how that affects the licenses of other apps, or if the UI is bundled with an app and how that's affected. So
for the Holochain gang who is here, it would be really good to set up some customs about how to license things so everything can work together. Because we want to, our goal is again is to put something out there that other people can use as well as us. So if there's a blessed set of licensing customs, we would follow them.